We are now starting the second phase of our papers, Mechanics M1, with the code 9709/42. Nine seven zero nine oblique 42 May June 2023. 1 hour 15 minutes is the duration. It is the mechanics paper 4, and we are using the second phase of that. Question statement is: a particle of mass 1.6 kg is dropped from a height of 9 meters above the horizontal ground. The speed of the particle at the instant before hitting the ground is 12 meters per second. Find the work done against the air resistance. Since in this particle is dropped from a height of 9 meters, question number 1, mass of that particle is 1.6 kg, height is 9 meters. Since they have used the word dropped, so that means initial velocity is equal to 0, and when it hits the ground, its speed is 12 meters per second. And you are going to find out the work done against the resistance. We know from this work energy principle that work done by driving force minus work done by resistive force is equal to change in kinetic energy of the system there. But work done by the driving force is the weight of that particle, which is dropped from the height A towards B of length 9 meters, coming downward to that. So here the weight is going to act, and here the air resistance or resistive force is going to act on that particle there. So we can use this part as weight into height, that is mgh minus work done by resistive force is equal to half m v square minus u square. Now mass is given there 1.6, height is g is 10 there, height is 9 minus work done by resistive force is equal to half, mass is 1.6, v square is 12 square minus u square is 0 there. So this and this cancel out. 16 into 9 is 144 minus work done by resistive force is equal to 0.8 into 144. So work done by resistive force is equal to 144 minus 0.8 into 144, and that thing is equal to 28.8. Since work done is measured in joules, so work done against the resistance is 28.8 joules of this portion there. Now we are going to start question number 2 of this. Two particles A and B of masses 3.2 kg and 2.4 kg respectively lie on the smooth horizontal table. A moves towards B with the speed of v meters per second and collides with B, which is moving towards A with a speed of 6 meters per second. In the collision, the two particles comes to rest. Find the value of V there. And the second part, find the loss of kinetic energy of the system due to the collision. So there are two particles A and B will lying on the smooth horizontal table. Let's say this is particle A, this is particle B. A is moving towards B and B is moving towards A, where A mass is 3.2 kg and B mass is 2.4 kg. Its initial velocity is V meters per second and its initial velocity is 6 meters per second. Its final velocity is zero, whereas its final velocity is zero because they comes to rest after the collision. Now you are going to find out the value of V there. We know that momentum before collision is equal to momentum after collision. And that is m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. m1 there is 3.2, velocity is there v, m2 is there 2.4, because it is moving towards a, so its velocity will become minus 6, which is equal to m1, that is 3.2 into 0 plus 2.4 into 0, because after collision they are going to be at rest. So this is becoming 3.2v minus 2.4 into 6 is equal to 0, or v is equal to 2.4 into 6 divided by 3.2, and that value is equal to 4.5. So our velocity of that particle before collision is 4.5 meters per second, which is the speed of this V there. Second part, they asked about the loss in kinetic energy. We know that kinetic energy is basically equal to half mv square. So kinetic energy for the particle A is equal to half. Mass of that particle is 3.2 and velocity of that particle is 4.5 square. So that thing is equal to 32.4 joules. Now kinetic energy of this particle B is half, mass of that particle is 2.4 and velocity of that particle is 6 square. So that thing is equal to 43.2 joules. Now they are asking about the loss in kinetic energy. That means what? Kinetic energy of A minus kinetic energy of this particle B there. Kinetic energy of A before that one is 32.4 minus kinetic energy of B, because it is moving towards A. So it should be equal to minus 43, sorry, 2.3. that is 32.4 plus 42.3, and that thing is equal to 75.6 joules. So this is the question 2 of that solution.